So let's start with this, and let's now actually calculate the height of this list container and therefore also of the chart container dynamically. To calculate that height dynamically, we need to know how much height we have available. And for that, let's go into the transaction list where we have that fixed height. Let's find out which tool Flutter gives us to calculate the height dynamically. How can we find out how much height we have available, what the general device height is? For this, there's a specific class we can use, the media query class. If you have a web development background, and specifically you know some CSS there, which is the styling language in web development, then you know that there you also have a feature called media query, which also allows you to write styles that behave differently on different device sizes or on different screen sizes. The media query class here is exposed by the Flutter material package, so we need to have that imported. And then here, just as with the theme, we have to connect it to our context with .of context. Because the context, as you know, is this metadata object with some information about our widget and its position in the tree. And as it turns out, this connection also allows us to find out which general device size we have available, because that's something which Flutter manages behind the scenes for us. And with media query of context, we can tap into that. Now that alone, however, doesn't help us. But with that now, we get an object where we can get all kinds of interesting information about our device. We can get the device pixel ratio, if we would be interested in that, to find out which screen density we have there. More modern devices have higher screen densities. That could maybe be useful for loading images or whatever you would want to do. You can find out whether the user opted that animations should be disabled, which you might want to respect in your application to not play a certain animation if that's disabled. But we haven't had a look at animations yet, so let's ignore that. We can find a couple of other pieces of information about settings the user set up. But most importantly here, you have a size property. And the size property gives you access to an object where you have a height and a width property, and that gives you the device height and width you have available. So here we could take the device height like this, and now this would of course be the full device height we have available. Obviously, in this case here, our container with the transactions should only take a fraction of that height, which is why we can simply multiply this height with a value between 0 and 1. 1 to take the full height, 0 to take 0 height. So here we could say we want to take, let's say, 60% of the available height of the screen. So we can multiply the available height with 60%. And if we do that, then you see I can no longer scroll this. And you see here the boundaries. This indeed only takes 60% of the available height, which is why now this container of transactions does no longer overflow our screen at the bottom. And if I shrink this further to, let's say, 0.2, well, then we see we get problems with our image here because this image isn't resized. We could configure that, but right now it's not resized. And therefore, here we're running out of space for that image. But 0.2 is a bit too small anyway, so for now, let's bring this back to 0.6. So this is not too bad. Now, at least this bottom container has a fixed height of only 60%. We haven't restricted the height of this container at the top here, though. And obviously that is something we could also do. If we go to our chart Dart file here, we can wrap this card here, let's say with another container, with the help of the refactoring tool, and assign a height here, which is also calculated based on the available height with media query of context, size, height. And then we had 60% on the list with the transactions. Here we could assign the remaining 40%. Of course, you don't have to make sure that the amounts add up to 1 if you want to leave some space unoccupied. But here, if we do match them, we see 40% seems to be a bit too much for the chart here. We have some empty space here at the bottom. But now we have that align up. And yet we can scroll that page. And that is really strange. Because if you think about it, we have 40% here on the chart, we have 60% here on the list, and if we have a look at the main Dart file, then these are the only two widgets we have here, chart and list. So why can we still scroll here? Shouldn't they add up to, well, the entire height, and therefore this should not be scrollable? Well, that's not the case because we also have the app bar here, and we're not considering the app bar in our calculations here. To do so, we can go to the main Dart file, which is where we create that app bar, and we can create that app bar in a variable, in a final variable, because I don't plan on changing it, and there I simply store my app bar widget. With that stored in a variable, we can simply assign that variable here to the app bar argument, so that we still create the app bar. Now, why am I storing it in a variable? Because the app bar object, which I can now access anywhere since it's stored in that variable, has information about the height of the app bar. So now here in main Dart, we can go down to the places where we create the chart and the transaction list. And now let's wrap both with a container here inside of the main Dart file. So I wrap my chart and I assign a height here of media query.of context size height times, let's say, 40%, just as before, but I want to deduct the app bar height from that. So I'll actually wrap my height here, the height calculation, into parentheses and deduct app bar dot preferred size dot height. Preferred size is a property we can access on the app bar to get the height that is reserved there, or the dimensions that are reserved. So now here we have an adjusted height where we deduct the app bar and then we calculate 40% of that adjusted height. And we should now do exactly the same down there on the transaction list. So I'll wrap it here with a container, still in the main Dart file. And then I will copy that height calculation, add it down there, but here I'll use 60%. Now important, you have to deduct the height of the app bar on both calculations, because we then use a fraction of that, and we want to use a fraction of the available space, and the available space is always full height minus app bar height in both cases. Now, since we calculate the height here in the main Dart file, we should not do it here in the chart and in the transaction list widget anymore. So let's remove our container here in the chart widget file and remove the closing parentheses, and the same down here in transaction list. I'll not do that here. Instead, I'll just return my ternary expression here without the container, because we have the container in the main Dart file. Now, if we save this and maybe do a full restart with the green arrow here to make sure that this really is all taken into account, we can see that here I still have a little bit of scrolling available, and this now comes from the status bar, which is another element we have here that takes some space. So we should also take that into account in our calculations. To do that, let's go back to the main Dart file, and in here, let's deduct something else. That's now a piece of information we can again get from the media query with of context, and there access the padding. This, as the information here also tells us, gives us the padding which Flutter automatically adds around our app for typical UI interfaces or typical UI elements like the system status bar. So here we can get the padding, and we want to get the padding from the top, which is for the status bar. Let's deduct it here from the available height for our chart and also for the available height of our list. And if we save this and do a full restart with the green arrow here again, and we go back, now this really isn't scrollable anymore, because now we have the full height of the device minus the app bar minus the status bar, and then we split that available space.